So now we will study about light. So let us see the introduction of light. So light is only form of energy that can be seen. Visual light is only a small part of the vast range of electromagnetic radiation. So light is the form of energy and it is the part of electromagnetic radiation, right? Which we see in our daily life. So like radio, electromagnetic waves are radio waves, television waves, radar, microwaves. So these all waves are electromagnetic radiation waves. So here it is written visual light. Before that it is infrared light. After that ultraviolet light, X-ray, gamma rays, cosmic ray. So these are the behaviors shown here. And visual light we comes between the infrared and ultraviolet ray, right? So in ancient Greek, a study both show that reflection, bouncing off of light from the surface and refraction, bending of light. Early scientists realized that refraction was a precise effect and tried to make a mathematical law to show that how much bending occurred. The Egyptian geographer Ptolemy carried out several experiments to investigate how far light was bent. This devised a law of expansion of light of refraction. Even his own result didn't always agree with this law, right? So there is a scientist, Greek scientist, which study about the law of light which bends towards the corner, right? So you can see that here it is system of light through which it is putting the light inside the glass and light is bent here. So write these 2 points, right? Light is the form of energy and it is the a small part of the electromagnetic radiation, and write the examples of electromagnetic radiation. So all these are examples of electromagnetic radiation like radio waves, television waves, microwaves, radar waves, infrared, ultraviolet, X-ray, gamma ray, cosmic ray. So these all are electromagnetic radiation waves. Look at the next point then. Alhazen, a scientist who investigate about the refraction of light which could not predict how far light would bend. However, Alhazen knew enough about refraction to make senses for the spectacles. The problem was resolved in 1621 by Wilhelm Snells, right, known as Snell's law. Snells found that when a beam enters or leaves block of glass head on, it doesn't bend. But if it enters or leaves at another angle, the beam will bend. Angle increases as the beam gets further from the head on position. Right? In found that it was a characteristics ratio between a beam angle of incident and angle of refraction. So this is called a Snell's law. This shows that at every medium has a characteristics of bending power called refractive index. The more a medium bends light, the larger is refractive index. So when mu is refractive index. So when it is large, then it bends the more light due to its more density, right? So this is done by the Snell's law. Snell's law predicts two angles. So when it is entering to the point, that is called angle of incident, and when it is coming out, that is angle of refraction, right? And it depends on the mu. Mu means refractive index of the medium. So mu will be the refractive index. So these are the two conclusions taken out by Snell's law. So read once. Now look at the next point. So Snell's also pioneered triangulation, a way to measure distance by using the angle between the different points. Okay, by using different points, you can find the distance between the 2 points. Why light bends? Now, our next topic is why light bends. A beam of light traveling from one medium to another medium, the speed of light is not the same in different media, right? So light speed of light doesn't, it depends on the media, right? So for example, light travels more slowly in glass than in air, because we know glass density is larger as compared to air. So refractive index gives the relation between the two speeds, right? Here written in vacuum, speed of light is 3 lakh, right, kilometer per second. But in water, you can see that its speed is less as compared to vacuum. So when particle become denser, the speed of light become slower, right? So it totally depends on the refractive index of the medium. Next point is the speed of light. Light has the largest speed of anything known. It travels through the vacuum empty at a constant speed of 3 lakh kilometer per second. However, light slow down when it travels through different material. So light year is the distance between in one year. So light year is equal to 1.5 million kilometer. So in 1 year, a light travels this much amount of distance, right? So write this one, then I will make you understand next point. Now look at the next point. Light year is a convenient measure of the stellar distance. Since the distance between the star is millions of kilometers, the sun is light minutes away from the earth. So light takes 8 minutes to reach from the sun to the earth, right? This means that light from the sun reaches us after 8 minutes, right? So it will take 8 minutes. So by using this, you can find the distance between the sun and earth, right? So because we know that now 1 light year equal to 9.5 million kilometer, right? By using this relation, you can find the sun and earth distance. Now next point is a spherical mirror. So a spherical mirror is the mirror that reflecting surface is curved part of the hollow sphere, right? So a spherical mirror is that mirror which is curved at the hollow sphere. A spherical mirror is obtained by taking a part of hollow sphere of glass or metal. There are two possible reflecting surfaces. So a spherical mirror is divided into two parts like concave mirror. If the part of the sphere that curves inside is polished, inside part is polished, serve as the reflecting surface, then such a mirror is called concave mirror. Next point is convex mirror. If the part of the sphere curved outward is polished, then that type is called convex mirror. So you can see there, this is your convex mirror and this one is concave mirror. So here outward part is polished, here inward part is polished, that is called concave. This was in convex. Now look at the next point, which we are using the terms in a spherical mirror. So first point is center of curvature, that is denoted by C. So center of a sphere of the mirror form a small part called center of curvature, that is written by C. Next one is radius. Radius of curvature is denoted by R. So any line that joins a point on the mirror with the center of curvature is called radius of curvature, right? And radial line is always perpendicular to the spherical mirror. So your spherical mirror is like this, and this point is called radius of curvature, right? From the center to the circumference. Now next point is pole. So it is the center of reflecting surface of the spherical mirror. So it is the center. Suppose center we take now. So this will be the pole, or it will be the center. Next point is principal axis. So it is the line through which pole and center of curvature line passing through the. So this line will called as principal axis, right? In which we write pole, center of curvature, focus. This is the main point in which we write focus, right? Next one is focal or focal point. So it is the point on the principal axis where the incident ray converge after reflection, right? So suppose we are taking this mirror. So when parallel rays are coming and it is meeting at a point, so this point is called focus. So F is called as focus. Or next is focal length. So look at this point. So focal length is defined as it is the distance between the pole and focus of the spherical mirror. Right? Suppose this is your mirror. So this is your focus and this point is P. So this distance will represent the focal length. It is denoted by small f and focus is denoted by capital F. Right? Pole is denoted by capital P. Radius of curvature is capital R. Center is C. Right. So these are the notation we use in the spherical mirror.